Well, good morning, everybody. I'm Eric Snodgrass, and I wanted to just send a quick video saying thanks for kind of your patience over the last couple of days as I've had a lot of trouble traveling. I ended up getting stuck in 3 different airports. The last one was last night in Washington, D.C., where a bunch of storms with some lightning just ended up forcing the cancellation of several flights. And I get it, the lightning was pretty intense across the D.C. area, and that was for the safety of those workers that were outside. Well, anyways, I decided last night, finally, I'm just going to rent a car and drive home. So I'm DC to Champaign. We're going to see how this all goes. I got to about Pittsburgh last night, ran out of gas mentally, decided to fall asleep here in this parking lot. So I'm up. I'm going to head home. But before I do that, I wanted to give you a little bit of a quick update on the weather, because just kind of sitting here by myself in the car all night, I had a moment to think about a few things with this pattern. I don't know, maybe it helped me figure it out a little bit. So let's get into this.
So here's what I've been thinking a lot about. It's this map here. This is just your last 48 hours of total accumulated precipitation. We've seen big storms make it all the way into parts of the Sierra Nevada and California, wrapping around what's been just an impressive upper level ridge that sat here that's driven this monsoon. We've seen isolated convection in the midsection of the country, but if you just notice, you go back, several weeks, this has just been the area from Texas, straight here through parts of South Dakota that has just had the wrong setup in the flow to really deliver moisture and deliver consistent rains. Instead, we've seen so much of that happening over in the Mississippi River Valley. Like, just look here. Yesterday, we saw even more heavy rain that came right through some flooded areas from the last several weeks. And then we've seen just isolated convection, a lot of big storms that have popped up here across the east, and they've been kind of sourced on quite a bit of Gulf moisture. Now, we come back to the same narrative we've been discussing for a while, and that is who's had and who's not had that precipitation as of late. So you look at this last 14 days of precipitation as a percent of normal, and I'm starting to, I think, just piece together what's going on here. So the Southwestern Monsoon has had a pretty far northward extent, and it has also at times been able to deliver moisture into Colorado, parts of Kansas, the panhandles of Oklahoma and Texas, while missing, just completely missing, Central Texas. Now, we don't expect the monsoon to get into Central Texas anyway, but there's been something else that's forced the missing of the moist air here. And they've had numerous days of exceptionally hot temperatures for this entire summer. And then we just watch this swath that's right in through here. In fact, you can even let it just extend. There's just a place in through here where we've really missed out on a lot of rainfall. But it's all been, extremely heavy, getting through Missouri into Illinois, over to Kentucky. So there's this corridor that's opened up right in through here that's been so wet. So just thinking about this last night, I wanted to again match it up with soil moisture data. So this is our latest 16-inch or 40 centimeter soil moisture percentile data from NASA. And what's going on here is we just continue to see an area that has deficits, and we would expect then that the lower atmosphere would have deficits in moisture here as well. Same thing for Texas. Come through pockets of the eastern Corn Belt, getting into New England. That's that corridor that has just simply not been able to get the soil moisture to recover. And why that's so important is if you have moisture in the soil, when the atmosphere has some sort of trigger to get air to rise, be it a thermal, be it a weak front, a decaying boundary from an old storm, doesn't matter. If that moisture's there, that local moisture source is there, then you'll pop those storms. But there are places where it's missed. So we've had these isolated events that have occurred inside of this dry area, but nothing widespread. Whereas we just keep pummeling this area that's got so much moisture already there that when you add the Gulf moisture to it, you just get more flooding. We've also started to see some pockets of drought redevelop down here in parts of the southeast. I think that's going to be critical too. So this is what I've been thinking a lot about. This is our mid-level flow, and I'm trying to convince myself here of what's happening. We continue to see lows that come through the Canadian prairie, and they kind of wrap up somewhere here. So they're leaving these weak frontal boundaries on which we could get storms to fire. But if you notice, our subtropical ridge in the Atlantic is kind of stretched here, and at times it kind of works its way into parts of the southeast. So it's really an elongated subtropical ridge. So the flow comes off of the Atlantic into the Caribbean, where the wind shear has been incredibly high and strong surface winds, and it does this. Now, if you notice, okay, if I put 2 arrows in here, it all looks like one piece of flow, right? But this is being sourced from the Gulf of Mexico, and it's juicy. This is coming off of Texas, where there's drought. And so what's happening here is that we're also not able to deliver this moisture straight from the Gulf through the Central Plains to get it up to these fronts that come into this part of the country. So I'm really concerned about that Western Corn Belt area. And I think this is really what's going on with this pattern. Now, from there, I want to show you this graphic because I think this is complementing that story. From the last 10 days of July into the first few days of August, this is a map looking at near surface specific humidity. So it's different from relative humidity. This is literally just how much moisture is in each kilogram of air. And now we can see it, right? So if you notice, there's the Southwest Monsoon, very robust moisture signal there. And again, that pulls in, here it pulls across parts of Mexico, and we just have really drenched this area with some incredible storms. But look at how low the specific humidity is right in through here versus how high it is there. So this is anomaly compared to normal. And there's that flow delivering here, but because of the way the flow comes across Texas, we have this area that we've not been able to return high moisture content air. Even though we keep talking about the Gulf being open, it's not getting in there. So what we end up seeing is we look at this satellite imagery, like here's just where the sun has risen. I think I'm somewhere right here right now. And if we just take this back to last night, you can see this. I want you to look here. You can see the circulation around that upper level ridge that is driving the monsoon. And notice it has delivered huge storms into parts of Texas last night. So we've seen big storms right there in the Panhandle. We've seen them in Colorado, and Mexico, Arizona, Utah. I mean, Nevada has had some heavy rain. We've even put rain right on top of Lake Mead, which has been so needed, and same thing for California. Now, to the north of it, we see wildfire smoke. So we can see it right up here, for example, coming out of right on the border, actually, of Montana and Alberta. And actually, that maybe is more toward British Columbia. And then see the large storms that try to pop in this heat right there on the border between Nebraska and South Dakota. Sorry, we've got a new image in here. Let's go back. But the real moisture is just coming here. And that's where the fronts are stalling. And so we end up getting this same discussion going. Flood, heat, flood. And we had serious heat in parts of the Northeast yesterday. So take all this, and I want to say, what is the atmosphere going to do with these two things? You ready? Let me step you up to 500 millibars. There we go. And these are the two features I'm watching carefully. Remember how we talked about yesterday there's going to be these two troughs? Well, this is where they are now. And what I'm watching with these two troughs is they're eventually going to get pulled into a frontal boundary tomorrow, that is going to try to work its way through the Western Corn Belt out of the Canadian prairie. And can these help, as they get pulled in this area, to increase the lift, to use what moisture is there to deliver some good rains to parts of the Western Corn Belt, which, as we discussed at the beginning of this, desperately needs it. Look at the soil moisture values again. So let's go through our three-model approach. This is from the WPC. This is their forecast for the next 7 days. And you start to see some pretty familiar themes, right? There's the sagging frontal boundaries, one that's coming through here. We'll talk about how much rain is going to get out of that front, looking at the other models in a second. We have the stalled out frontal boundary that sits here. That's really just pulling on all that Gulf moisture. So you can see where that Gulf moisture is going, right? Drier on this side because of the proximity to the subtropical ridge. Drier on this side because the flow's coming out of Texas rather than out of the Gulf. But how much can we recycle if there is moisture in this area and combine it with some Gulf moisture to really build out some storms in some places that need it? And there's also another question. If this monsoonal circulation stays so strong, with the evolution of the ridge we've been watching that keeps just meandering somewhere between the plains and the Four Corner states, will it be able to draw some of that moisture possibly into the plains? Some of the models are suggesting that. So this is the WPC, so this is the National Weather Service product. That's the European over the next 7 days. So do you see how right in through here, there are isolated chances of storms, but as you go toward the Mississippi Valley, then eventually the Ohio and Tennessee Valley, the chances increase considerably. This is the GFS. Now, European GFS. What is very interesting is that now the GFS, which has been really kind of all over the place, has increased rainfall in a state that really needs it. And I was here, I don't know, I guess it was 3 days ago now, and I'll tell you, this part of the western Corn Belt, Nebraska, needs this. So this is what's neat. This is the latest comparison between the ECMWF and GFS on the 0Z run last night. We've made a comment that the European has been the wetter model. That would be these colors. If these are the colors you see, that would be where the GFS is wetter. So now we see that getting over toward the Mississippi Valley, for most of this next pattern sliding through where the fronts are going to stall out, the European's wetter. But the GFS is wetter here. And so therefore, let's go see what's going on to make all this happen. I'm just going to show you the European. We're looking for features here, okay? So here's the low today. And as we play this forward, let's get to Friday evening. Stalled out frontal boundary, plenty of moisture, isolated storms, and I imagine even more flight cancellations. Here's the low that came out of parts of Saskatchewan, moved through Manitoba, and is going to go straight toward the Hudson Bay. And it's going to leave this front right here. Now, this is Friday night tonight, so we're going to watch for storms to build down that front tonight. We then get into Saturday morning, Saturday afternoon, and evening. And notice that front didn't move very far. But what we are going to see with this particular front is those two short waves behind it. Will they be able to link up over the top of it? Because by the time we get to Saturday, the front's really only moved about a half a state over. We still have the isolated storms on Saturday night, running from parts of the Tennessee and Ohio Valley, clear into parts of New England, and then along the Gulf Coast. So then we go from Saturday in the overnight hours into Sunday morning and Sunday afternoon. So do you see that additional rainfall coming through South Dakota, Iowa, parts of Minnesota? That's where the upper level shortwaves I pointed out a few moments ago, one was here, the other was there. That's where they're enhancing the lift. But that front stays pretty far to the north in the European model. So this is now Sunday night. Isolated storms will build right on this boundary. And that's where I'm watching it most carefully. Whoops. So we get into now Monday morning, afternoon, and evening. And now the front's advanced farther. And then we get out here into Tuesday morning, afternoon, and evening. So do you see that slowly sagging front here with high pressure behind it? It's just going to make it back over the same areas that have been so wet. But the systems break up in through here. A lot of isolated, scattered events rather than just a continuous line of heavier rainfall like we've been getting in this area. So that's what I was trying to diagnose and just think about last night as I was driving. So we get out here to next Thursday and into next Friday, and higher pressure is already built in. But what's very interesting in the models is that late next week, we're starting to see some indications next weekend that we could extend another setup like we have now with a low going over the Hudson Bay with more of that moisture coming out of the Four Corners states, maybe extending into the plains. That's rare. I don't remember a lot of times in my career forecasting moisture from the monsoon to get here into the central plains to deliver rainfall. But I can tell you this upper level high pattern could help with that. So what we're watching here is through this weekend and into early next week, and I'm just trying to figure out where the ridges are going to rebuild. Because by next Tuesday, we see it sitting right here over the Four Corners states. But with time next week, next Wednesday, Thursday, Friday, it just migrates back into the central part of the United States. There is a big difference in this pattern, though, once we get it out here. Let's just stop it on day 10, which would be the 15th of August. And the difference is this. That trough now sitting over the Canadian archipelago, it spent time in Alaska at some points. It spent some time here. But now the models have got it forecast to sit there. So you get this pattern that does something like this. And that moves the ridge farther into the central United States. Now the farther it moves here, maybe the more we can pull that flow around and give us those ridge riding storms. But unfortunately, it means we're going to see some drier conditions, and the models are seeing that. But take a look. This is the week 2 precipitation pattern, and the European model's pretty ambitious about delivering better rains here. It's a lot to still be seen if this unfolds, but it's got some drier conditions back in this area stretching into parts of New England. Now, just for completeness, this is what the GFS says. That's the week 2 precipitation pattern, the 12th through the 19th. Again, European versus GFS. Now, with all these changes, you can expect a pretty highly variable temperature pattern. Here's Friday's high temperatures. This is another round of extreme heat in the midsection of the country. So then we go into Saturday. There's the front advancing. From Saturday into Sunday, major swing in temperature. We could see a 30-degree swing in temperature right here from today through Sunday. Heat's in the corners, the northwest and northeast, see here and there. And then as we play this forward into Monday, that front slides through, but then the heat comes right back on Tuesday into Wednesday in the midsection of the country. So as we play this out, just for completeness, out to next Thursday, this is when the pattern seems to go back over into that reset mode. And the ensembles are getting it as well. So 5-day sliding window. Let's just play this on out here through the middle of the month. We're going to park it on day 10, which would be the 15th. So that's day 5 through 10, the 10th through the 15th. And then we let the model go on out. As the ridge reopens in the midsection of the country, the above average temperatures come back on. So in other words, if we get the heat back in place, we need more routine storms to outdo the evaporation from this as we go through the middle the middle part of August into the third week of August. Okay, there's one other component to this I want to discuss with you, and it has to deal with the tropics. Some pointed out the other day, a lot of great experts I was talking to on tropical cyclones had mentioned that one of the things that's occurring coming off of Africa, besides all these huge dust plumes, is that the waves are breaking. So in other words, instead of saying like an open wave, an African easterly wave, they're breaking and folding, and as a result, not allowing for the initiation of tropical thunderstorms to really survive. So these big wave break events like this one here, or the one that's now moved over by the time we get into early next week into the Bahamas. So it's also dusty and it's dry, and we've really had a very slow start to the season. Let me show you. This is a graphic put up by Colorado State University looking at something called accumulated cyclone energy. We flatlined so far. Normally August is the month where things really ramp up, and then they reach a peak in September before waning in late October through November. So here we are with really not a whole lot to talk about. And NOAA just updated their forecast yesterday on the 4th. Let me show it to you. This is their new seasonal outlook. So they're still calling for an above average season, but they've tucked their number of named storms somewhere between 14 and 20, with 6 to 10 hurricanes, 3 to 5 of which are major. So those numbers are just a little bit above the normal. Colorado State, also updated theirs as well. And I think this is good forecasting. When you see the pattern evolve and change, then it's important to make adjustments, and that's what's so good about them. So they adjusted down. They're now down to 18 named systems, 150 accumulated cyclone energy versus 180 was a previous forecast. And so this makes sense given what we're making it into August and have yet to see things really ramp up. It does appear that we could get a lot of what we call homegrown systems this year, which means watch the Gulf and watch the southeastern part of the United States and just off the coast for possible tropical development as we work our way through the next several weeks. Again, I just thank you for your patience this week. I do have to go to Tennessee for a couple of days and then New York for a day next week. And I don't know, I may just rent a car and drive the whole thing because I've had a difficult time with the weather and flights. But I'll leave it there, and I'll talk to you again after the weekend. Thanks.